Hello, viewers. In today's session, we are going to discuss one important problem from Dirac delta function, right? So here in this session, we are going to solve this integral in which we have the limits minus infinity to positive infinity, log of 1 plus x cube sine pi x over 2, and the Dirac delta function of x cube minus 1, right? So here the argument is a function that is a cubic function x cube minus 1, right? So we'll see how we can evaluate these kind of integrals involving the Dirac delta function, in which we have a function in the argument of delta function, right? So let us start. So to evaluate these type of integrals, what we do, we use an important property of Dirac delta function, right? See, suppose we have an integral, say minus infinity to infinity, and here we have some function, say f of x, and here we have delta of g of x dx. Then delta of g of x can be written as delta of gx, and here we can have sigma I is equal to 1 to n delta of x minus xi divided by the absolute value of g prime of xi, right? So whenever we have to evaluate an integral of this kind, in which we have a function inside the Dirac delta notation, then the delta of g of x can be given by this formula, right? And here xi's are the roots of the equation, that is g of x is equal to 0, right? So what we do, we solve the equation g of x is equal to 0, and xi's are the roots of this equation, right? And then we find the derivative of g of x, and we calculate g prime of xi, right? Where this I, it runs from 1 to n, right? So here we are considering the n roots of the equation g of x is equal to 0, right? So now if we compare this integral with this one, then this is our function f of x, right? Log of 1 plus x cube sine pi x over 2 is our function f of x, and g of x is equal to x cube minus 1, right? So now what we will do, we'll solve this equation g of x is equal to 0. So we have x cube minus 1 is equal to 0. So this is a cubic equation and it has three roots. So now this equation x cube minus 1 is equal to 0 has three roots, and if we factorize x cube minus 1 cube, then we have x minus 1 x square plus x plus 1 is equal to 0, right? So we have x minus 1 is equal to 0, and x square plus x plus 1 is equal to 0. So from here we get x is equal to 1, and this is a quadratic equation, so it has two roots, but we can easily see that this quadratic equation has complex roots, right? So here we'll omit or will neglect the two roots which are complex, because the discriminant of this equation is negative, right? So we'll consider only x is equal to 1, right? So x is equal to 1 is the only real root of this equation x cube minus 1 is equal to 0. So now the next step is to get the derivative of g of x, right? That is g prime of x. So the derivative of g of x is g prime of x, which is equal to 3x square, right? Since we have only one root here, that is x is equal to 1, so we can denote this root by x1, that is equal to 1, right? So we'll find out the absolute value of g prime of x1, because here we have the value of I is equal to 1 only, because we have only one root, right? So the absolute value of g prime of x1 implies that is mod of g prime of 1. So we have mod of g prime of 1. G prime of 1 can be obtained by taking x is equal to 1 here. So we have 3 times 1 square. So we have here 3, that is equal to 3. Mod of 3 is equal to 3, right? So now we have to apply this property, right? So delta of gx. Now delta of gx is equal to sigma of I is equal to 1 to n, but here we have only one root, so we have the value of I is equal to 1, right? So we can write delta of simply delta of x minus x1 divided by mod of g prime of x1, right? Okay, so we have delta of x minus x1. X1 is 1, because we have the only one root, that is x is equal to 1. So here we have 1, here we have mod of delta prime of 1, and here we have delta of x minus 1, and mod of g prime of 1 is equal to 3, right? So delta of g of x, it implies delta of x cube minus 1 is equal to delta of x minus 1 over 3. So now let us substitute this value in this integral. So now let us take this integral as I. So we have I is equal to integral from minus infinity to infinity log of 1 plus x cube, and here we have sine of pi x over 2, and delta of x cube minus 1 is delta x minus 1 over 3, and here we have dx, right? So let us take this 1 over 3 outside the integral. We have 1 over 3 minus infinity to infinity log of 1 plus x cube sine pi x over 2, and here we have delta of x minus 1, right? Okay, so now to evaluate this integral, we'll make use of the definition of Dirac delta function. So now the Dirac delta function is defined by this integral, that is minus infinity to infinity. If we have f of x, delta of x minus a dx, then the value of this integral is equal to the value of this function at this point, that is x is equal to a, right? So this is f of a. So this is our basic definition which may be utilized to evaluate this integral. So here what we can do, we'll take this function as f of x, right? And here delta of x minus a, so our a is equal to 1, right? So now we have 1 over 3, we have the factor 1 over 3, and then we have log of 1 plus x cube sine pi x over 2, and we have to evaluate this entire expression at x is equal to 1, right? Because integral minus infinity to infinity f of x delta of x minus a is equal to f of a, because we know that the value of the Dirac delta function is only at this point, that is x is equal to a. So the spike, it exists only at this point x is equal to a, and at all other points the delta function is 0. So now if we take x is equal to 1 here, then we have 1 over 3 log of 1 plus 1 cube sine of pi by 2 times 1, right? Okay, so this is 1 over 3. Then we have log of 1 plus 1, that is log of 2. And here we have sine pi by 2, and sine pi by 2 is equal to 1, right? Because sine 90 degrees is equal to 1. So here we have 1. So this is 1 over 3 log of 2, right? So viewers, the value of this integral is equal to 1 over 3 times the natural log of 2. So viewers, this is how, by making use of this important property of Dirac delta function and the definition of Dirac delta function, we can evaluate or we can compute the values of these type of integrals.